Hi, welcome to the second demo video on SPK CGN. The use case for today is a GitOps with a SPK. The objective of this demo is to demonstrate the true cloud native of SPK. So, what does it mean by cloud native? Let's see the official definitions of cloud native from CNCF. So this is the definitions of the cloud native by CNCF. Cloud native technologies empower organizations to build and run scalable applications in modern dynamic environment, such as public, private, and hybrid cloud. Containers, service meshes, microservices, immutable infrastructure, and declarative API exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable, combined with robust automation. They will allow engineers to make high-impact changes frequently and predictably with minimum toil. The demo today that I'm going to run is to demonstrate some of the capabilities here. For example, do some high-impact changes frequently, and as well as some of the robust automation. The environment that I'm running, as well as the systems are loosely coupled systems where I have many different pods they are running together. Right, before that, let's have a quick recap of the environment. For details of this CGN Net64 and Net44, please refer to the previous video. Here is I have an environment. I have the ArgoCD with GitLabs set up in the UDF. So what I'm going to do here is that the ArgoCD are all pre-configured to link together with the GitLab. So I'm going to use ArgoCD to deploy the application onto the Kubernetes. And what happened here is that ArgoCD will constantly monitor the state of the F5 TMM, or to monitor the state of the application in the Kubernetes to make sure that it's always synchronized with the Git repository. What I'm going to do here is that I'm going to do some changes to the Git repository. The moment if I do a code commit in the GitLab, ArgoCD detected that and instantly will do the synchronize of the configuration to make sure that the configurations within the Kubernetes are always synchronized with GitLab. By default, ArgoCD will run every 3 minutes to make sure that the config are synchronized. However, in this environment, whenever a Git commit is run, so it will trigger a webhook for ArgoCD to do the refresh. I've pre-logged into my UDF. Here is my SPK. I log in in a jump host and 2 jump hosts and 1 backend server. And I have RDP to the desktop host. Okay, let me log into the ArgoCD. Yep, so now currently I'm logged into the ArgoCD and I have pre-deployed a CNF and a gRPC manifest. So this is all the gRPC certificate, DSSM certificate, as well as the network attachment definition. Now what I'm going to do is that I'm going to create the F5 DSSM. I call it the project name as F5 DSSM as well. Make it auto prune and self-heal of the containers. So here I define where is the repository. So this repository, my SPK, is coincide with, let's say if I log on to the GitLab, you can see there's a repository called my SPK, and within my SPK there are multiple folders. The F5 DSSM is one of the folders there. F5 DSSM, and you need to define where you want to deploy your applications in this Kubernetes. This is SPK Kubernetes and my SPK, and you reference the Helm chart that I have already pre-created and located inside the Git repository. So all these things you can actually create it using one single applications, one single deployment manifest. For this demo, I deploy it individually for the CNI gRPC as well as the F5 DSSM. So the moment I create the F5 DSSM, what happened here is that ArgoCD will check with the repository, and it detected that there's a differences. Hence, it will deploy the application port based on the configuration manifest that I have defined in the Helm chart. Now you can see that ArgoCD is spinning up the F5 DSSM and as well as the Sentinel. While waiting for that one, let me quickly run through what is in the folder here. In the SPK or the GitLab, they are the CLI gRPC, they have CGNet and F5 DSSM as a folder. And this is the Helm file that I'm using. So you don't necessarily need to interact directly with GitLab. So what I had here is that I've installed Visual Studio Code. In fact, you can just interact directly from here. It's the same things. You can see that there's a My SPK folder, and within here it is the same as what is in the GitLab. So you can do the code commit as well as the changes into this repository. Alright, I'm not going to wait for all the database to be spun up. So now what I'm going to do is that I'm going to create the SPK. I'm going to deploy the SPK. So my SPK project name, I called it the same thing as well, my SPK, and I'm going to do automatic prune self-heal. For details on how to use the ArgoCD, please refer to the ArgoCD official documentation. Repository, point back to that one. I'm going to use the F5 ingress because F5 ingress will deploy the F5 TMM. SPK. Here's the Helm chart that I had created in this. I'm going to create. So the same things, the same process will happen. So once I say create this my SPK F5 application, so the ArgoCD will do a clone of the repository and check what's the differences between the ArgoCD and the repository and start deploying the application. If I drill in, you can see that it's actually created a lot of all this CRD config map secret services, as well as all the CRD that is used by the CGNet. Yep, you can see that the F5 TMM is spun up within probably 20 minutes or less than that, and it is in the state of up and running. This is the F5 ingress is up and running within 20 minutes or subset less than 30 minutes 30 seconds, sorry. Now this is the F5 AFM that provide the CGNet function. Okay, so now as in the first video, what happened is that I need to make sure that as per what is explained previously, I have the LSN pool defined here. I have to make sure that my web server here know how to return back, because in a production probably you will have routers, and the routers will receive the advertisements of the LSN pool and know which F5 TMM to return back. In this demo, I don't have a routers, so I have to set a static route on this web server to make sure that for those LSN pool, it know where to send it back. So the way that I can find out is that I just need to check what is the IP addresses, what's IP address of the SPK on the right side, which is 2023. 23. Save this and run. So what I mean is that when it hit the backend web server, with F5 TMM will net it to 10.10.10, and the web server know how to get back to the F5 F5 TMM. Alright, so now you can see that I have my SPK is currently running healthy and sync. So I haven't deployed any CGNet configuration yet. So now I'm going to create the CGNet configuration. CGN. Point to the same repository. The path is CGN, and specify the same thing to the my SPK. Alright, so I'll try to create. So what this does is that it's actually create all the custom resource definitions for the publisher, net policy 1, secure file 46, secure log profile, and etc. In fact, if you look into the log here, you can see that the configurations block are actually push. Okay, let me see if I run the mctr debug. You can see that I only set up one. This is the net46 secure file for HTTP. So what I'm going to do is that now I'm ready to run traffic. So make sure that I'm running IPv6 only interfaces. I put IP and 6R. So default gateway is to the ECMP routers. So if I go http web1.spk.local, yep, you can see that actually I managed to connect to the backend server on 10.1.20.31.80 and 10.10. This is the client netted IP address and 5041. Alright, there's another places that you can check the logs, which is a high-speed logging, the data logging. All the data logs, data path logs are actually sent it via high-speed logging to Elasticsearch. Go to Discover. You can see that the logs later will, once you get more logs, it will get into that. You can see that the client IP and the client port are constantly changing because I'm doing a source netting dynamic path. Alright, so now what I am going to demonstrate the flexibility of the CGNet of SPK. If I try to curl to HTTPS site, this one will fail because there isn't any. If you look at the resources here, I only created the secure fast L4 for HTTP. Now what I need to do now is that if I want to create the HTTPS virtual server, it's very easy. What I need to do is that I just need to create a CRT file and deploy into the CGNet folder, and automatically the configuration will be propagated down to the AFM and to the F5 TMM. So I have pre-created a few of these. What I'm going to do is that I'm also creating the net44. This is a net44 configuration for the HTTP and HTTPS, as well as a net64. These are all the configuration manifests that you will use to configure SPK or configure the CGNet. So what I'm going to do is that I'm going to move all this into the folder. So the moment if I move it there, so what happens is that I haven't code commit yet. So I want to show you what happens if I do a code commit. CGNet 64 and CGNet 44. So I'm going to do a code commit to the master branch. So once I do a code commit, you can see that ArgoCD will do the synchronize web immediately. You can see that the CGNet is actually now is synchronizing, and it actually pushed the configuration down. This is a log on the AFM that shown that actually it is pushing the configuration down. If I run the TM debug, now you can see that there are those are the additional configurations that I push it down. Live HTTPS 4.6 and 4.4. So what it means is that if I run HTTPS, now you can see that I can connect to the backend server on 10.1.20.31 on 4.4.3 and 10.10.10.17. You see, it's so easy, it's so flexible that I can actually do configuration changes on the fly without touching any of the configurations of the CGN configurations. So what I need to do is just do a code commit. Alright. So now what happens is, let's say for example, if I want to do a scale up, for example, currently if I go to the SPK, apps, you can see that currently I'm running one healthy F5 TMM and one AFM. So what I'm going to do now is that I'm going to demonstrate the elasticity of F5 TMM, where you can actually easily scale up and scale down of the F5 TMM. So what I need to do is that if I go back to the VS Code, what I need to do is that I go into the F5 ingress, I modify the Helm chart. Currently you can see the replicate count is 1. For example, if I change it to, let's say 3, I want to scale up to the 3 port. I save it. Now what I'm going to do is that I'm going to do a code commit. Let me get out from here. I'm going to do a scale up of F5 TMM. I commit, and then I'm going to push it, push the config down to the master branch. And so once the code are committed, you can see that later on this one will be out of sync, and immediately it will do the do a synchronizing because it's out of sync, because the Git repository is out of sync with what is in the ArgoCD. So now what it is going to do is that you can see that it's going to spin up another 2 port. Now this 2 port will be running on 1 and 2. So now you can see that it's actually trying to build another 2 port. Yep, you see, less than 30 seconds, 2 of the another additional F5 TMM are spun up. From this demo, you can see that how lightweight and how flexible the F5 SPK for this CGNet. If I move back to here, I can see that if I try to look back, you can see all these ports are deployed, F5 TMM deployed in node 1, F5 TMM node 2, and in node 3. You can also as well see the port that is currently running in a healthy stage. Alright, what happened, just for the sake of, if I scale it down to 1, save it, scale down, do a code commit. So this is out of sync. So later on, 2 of the port will be removed, will be terminated. Yep, you can see that these 2 ports are no longer required and it will be terminated. Okay, in this demo, I'm going to show you how you can create SPK to load balance traffic inside the Kubernetes. In the demo that we did just now, what happens is that it's actually the F5 TMM is actually doing a CGNet to the outside of the Kubernetes cluster. So in this one, I'm going to show you how you can actually send the traffic and get F5 TMM to load balance to the Hackathon application. So the same thing, I'm going to deploy the my Hackathon automatic. The repository is in my Hackathon, and Hackathon, the destination, which is the Kubernetes, and my Hackathon. So what I'm going to do is that this one I will do auto create the namespaces as well. So what I'm going to start the creations of the application. So the same thing, you can see that it's trying to build and try to synchronize with the SPK, synchronize with the Hackathon. So as part of the deployment, I deploy the secure fast L4 as well. So in the Hackathon here, I deploy a manifest called a CRD called the F5 SPK ingress TCP, and have this listen on port on IP address 100, 100, 100, 100. And what it does is that it actually will load balance to a Hackathon service. Alright, so if I look into the logs here, or logs in the, okay, if I run config viewer, you can see that the configuration, this is basically config viewer is actually to check the configurations inside the F5 TMM to see what's been created. You can see that I created the Hackathon fast L4. Alright, so now what I'm going to do is that if I go to the client, this client, I just want to make sure that it's IPv4, because that application is actually is an IPv4. I'll take ping 100, 100, 100. Yep, if I local HTTP 100, 100, 100, 100. Yep, you can see that I can connect to the application. 100, 100, 100. Yep, I'm actually connecting to the application which is reside inside the Kubernetes. If I try to run the config viewer again. You can you should be able to see the pool member. The pool member got discovered by F5 ingress on this 3 port, which is correspondent to the 3 HackerZone applications that I have deployed inside the Kubernetes. Pretty much it. Thank you for watching.